Trains are great. I love it. So my name is Chris. I work obviously for this company, the shirt I'm wearing, so I work for Twitter. And the most important question of the day, and it's good that it's kind of the first talk of the day, because I ask this question all the time. So who in this room has a Twitter account? Yeah, that's pretty good. I mean, that's more than half. That's very good. So all you other guys, you have to create one right now. And because I'm asking you to tweet about my talk, obviously, but also about the whole Vox days and all the other talks, and that people know what was going on. And I think the videos will be online later so they can rewatch and so on. So Twitter has, I used to say, a small VM team. It's not so small anymore. We hired a bunch of more people. So we are now, I lost count, probably 6, 7, 8, I don't know. So we have some core people that work on the VM, then we have other people that do different things that are VM related. So if you're going to tweet about my talk, you should add this hashtag TwitterVMTeam so that my team knows that I was actually here and not doing something else, maybe sit on a train in the wrong direction. So what's the goal of this talk? It's very important. A talk needs to have a goal. And the goal of this talk is to save money. So we did that at Twitter. I'm going to present you everything that I've basically done in the first year after I started at Twitter. And I'm just encouraging you to try this as well, right? It might help you, it might not. We go into the details later, but we at Twitter, we save a shit ton of money. I have to be careful what I say because it's being recorded, but it's true. So for those of you who don't know me, my name is Chris. I work on JVMs for a very, very long time. Most of this time, I was working on compilers. I'm just asking, I'm not talking too much about compilers in general anyway, but who knows what a JIT compiler is? Okay, good, yeah, that's great. I've given talks with hundreds of people in the room and 2 people raised their hands, so so this is a good crowd. I started to work for some microsystems back in the day. That was really cool, and then Oracle acquired us, and I was always part of the hotspot compiler team, so I was most of the time working on C2. We're not talking too much about C2, but do people know what C2 is? Like the server compiler in Hotspot. It's the peak performance compiler in Hotspot. People know what Hotspot is. Yes, OpenJDK JVM. Yeah, you know that. So it's one of the compilers. So I was working on that. The 3 most, I want to say the most important ones, but the biggest ones, biggest 3 things I worked on during my time at Sun and Oracle was JSR 292. So I worked on Invoke Dynamic from the very beginning with John Rose. So I implemented a lot of that stuff. I implemented a lot of basically all the compiler support, and then there were 2 implementations. One was a lot of handwritten assembler. That was really nice. That was a lot of work. But then we decided that's not maintainable, so we moved a lot of that logic into Java, into the Java Lang invoke package. So there's a lot of Java code now that does that. I wrote a lot of that code. So if it doesn't work, you could technically blame me, but a lot of people worked on it after me, and they probably broke it. My code was fine. Then we did CHEP 243. We're going to talk about this a little bit more later. It's the Java level JVM compiler interface. So it's basically the interface between a compiler that's written in Java, like Graal, and the JVM, which is written in C++. So you need an interface. And so we extracted the interface from the Graal project and said, OK, we kind of standardize. It's not really a standard API, but we kind of standardize it, put it in Hotspot in OpenJDK, and then we have an interface. So that's 243. And we did that in Java 9. And also in Java 9, we did JEP 295, which was an AOT compilation tool. It uses Graal as the code-generating backend. And it uses, obviously, JVM CI because it's using Graal. So it's basically a command line utility. It loads in classes, and then it compiles them and spits out a shared library at the other end. That's all it does. So you can do that since 9. And now I work for Twitter, which is great. I love this company. It's a good company. I'm sure you know what Twitter is. I'm just, some facts. It's a huge distributed system, right? So we have many, many, many microservices, hundreds of microservices. The 4 biggest, most important ones, obviously, is the tweet service. You want to read and write tweets, right? Then you have a user service, which is all the user data that is associated with your accounts, and a timeline service to build up your timeline, a social graph that has the interactions between the users, and so on. So these are kind of the biggest ones that we have. And each of these services runs on a ton of JVMs, right? We have thousands of machines running thousands of JVMs of these services. And we do that in multiple data centers. So we are quite big. We're not as big as, let's say, Google or Facebook, but we have a decent size. So if you can save some CPU time, that multiplies, right? And that also then gets translated into money, and that's where the money-saving part comes in. And this is what we're doing. So Twitter, well, let me say the other thing first. We're using a lot of open source. We really do. We love open source. But we also have a lot of open source projects. So there's this one website at the top, and then we have a GitHub, what's it called? I always forget what it's called. So you can go to that link, and then you see all the open source projects that we have. And so for us, Graal is a very good fit here because it's open source, and we can just take it in and integrate it into our JDK, and we're also contributing back. So I'm giving you one example later that we contributed back. But since then, the slide deck is kind of old, but since then we are contributing back more stuff, especially in regards to optimizing Scala code. Okay. So as I said, we have our own JDK. It's based on 8U. Yes, we're still on 8, like everyone in this room is, right? Or 7. And so our 8 is slightly different. It contains JEP 243 because we need it, right? So we backported it from 9, kind of. Then we took a Graal version from GitHub, like a verbatim copy, git clone. That was it. Then we have something, or had. It's still in 8. It was called Contrail. It's basically, you guys know what JFR is, right? And JFR was closed source back in the day, so we re-implemented JFR and we call it Contrail. We wanted to open source it, but then Oracle beat us to the punch. But that's better anyway. So we are going to take a bunch of improvements that we did for Contrail and upstream it into JFR. We're working on this a little bit. And we still have some CMS improvements, but CMS is dead anyway, but we're still using it a lot, which is a problem going forward, but I'm not talking about that. Don't ask me cheesy questions, by the way. Why Graal, right? So I briefly mentioned C2, and it's a very old and very complex compiler. I worked on it for many, many years. If I tell you it's a piece of crap, then you can believe me. The learning curve is very, very steep. So one of the issues we have when Oracle acquired Sun, that some people left. They were unhappy with how Oracle was running the ship, and so they left. And then we tried to hire new people. And some of these people had previous compiler experience, some did not. And for them, it was very, very difficult to learn the code base. When I started working on C2, and I've worked on JIT compilers before, honestly, it took me 3 to 4 years to fully understand how the thing works, right? And it's mind-blowing. For people today, you go on GitHub, you download a framework, you look at it for 2 weeks, and you understand it, right? And then you're happy and you do stuff with it. If you get thrown a pile of code in front of you that you don't understand after 2 years, you'll be frustrated, right? And that's what happened. People got frustrated. They thought, I don't know what they were thinking, but they probably thought, oh, I'm stupid, or I don't know, this is a piece of shit, I don't want to learn this anymore, it's too hard, too complicated. And that's a problem, because going forward, I'll retire at some point, and we need other people work on the compiler, so we need something that's easier to understand, right? And Graal is that, right? So, and then in C2, in the last years, I should rephrase that, I should say the last couple years, there were no major optimizations in C2. There were small improvements we did, or one of our colleagues did an improvement to have better inlining for invoke dynamic method handle calls and so on. Most of the improvements that were were made by Intel, by writing better and wider, handwritten compiler intrinsics with AVX 512 and so on. But this is not really a compiler optimization per se. It's an architecture-specific optimization that a human does by writing assembly code. That's not really it. And then, in my personal opinion, C2 reached its end of life a long, long time ago. It's just way too complicated, and it has. Yeah, I don't. Yeah, I could go on and on, but I'd rather not. So Graal is easier to understand. Mainly because it knew about the issues in C2, and it was from ground up designed as a modular compiler. The build system that Graal has, which is a very, very ugly, I think, 5,000 or 10,000 lines of Python script, one file. And that build system makes sure that the dependencies, you don't violate the dependencies between the modules. It's not a module in the JDK9 sense, it's like a group of packages that the build system, it's basically modules before modules were there. And because it works on 8 as well. So it makes sure that you don't have dependencies from architecture-dependent code to architecture-independent code, happening all the time in C2. And so it makes sure you're not breaking these, and it makes sure that the code base is sane and fine. And so these are, that's a very old screenshot, but it's like there were 80, at one point 80 of these modules, right? And then these modules contain multiple packages. And you have architecture-dependent packages for all the CPU architectures that you support, and so on and so on. Okay, then very important. It's kind of, I have to put this on another slide, like a very big. Graal has better inlining and escape analysis than C2 does. That's actually the most important part for this whole talk, because this is what it's going to boil down to. So the inlining is just the way inlining is done in C2 is a little restrictive. The heuristics are a little too conservative. That has many, many reasons, mostly historical reasons. And escape analysis, I'm not going too much into escape analysis, but there is like the typical standard escape analysis implementation that was described in the paper, and then there was another an improvement on top of that later called partial escape analysis. And Graal does partial escape analysis, which can eliminate more object allocations. Not going into detail here, but Okay, so as I said, it's basically the first year of my Twitter experience, and when we started running services, and I think I started with the tweet service, that was my first guinea pig, we hit a bunch of bugs, okay? So, and I'm walking you through them now, and then you'll see the issues we found. So the first one was, I'm not going to explain what OSR compilations are. I think that's a little too complicated for now, but it means on-stack replacement. So when I was running the service and I turned on print compilation to see what's happening, I saw these OSR with locks not supported flyby, right? And thought, okay, yeah, that's not good. And then you get an exception because Graal is written in Java, so you get a nice compiler exception and you see where it's coming from. And in this case, it comes from an on-stack replacement phase, and it says, yeah, I can do this with locks, okay? Well, whatever. So Tom Rodriguez and I, he's an engineer at Oracle Labs. I forgot something on the previous slide. Graal is developed by Oracle Labs, right? And a big chunk of the Oracle Labs team is now in Zurich, okay? So you're kind of obligated as a good Swiss citizen to use the compiler, right? Okay. I'm trying hard to convince you. So Tom and I, we discussed this, and then we decided it's not a big issue, and the reason is because, do people know what tiered compilation is? Okay. So Hotspot has two compilers. I told you about C2, and there's also a compiler called C1, and they have also the name client compiler and server compiler. You might have heard that before with the dash client dash server. which is obsolete now, don't use it. So tier compilation, what it does is you run your application, and then what the VM is doing is it interprets your Java bytecode, which is very slow. And then it collects a little profiling data, and then it starts compiling with C1, which is a high throughput compiler. So it produces quickly native code for you so that you're running a little bit faster. But it compiles code in a way that it collects even more profiling data, and then after a while, it recompiles with C2 using all that profiling data and producing peak performance code so that your application actually runs fast. Okay? And so you're walking through these tiers, that's tier compilation. Okay? So we are running Graal. The default setup is running Graal with C1 and Graal. So usually it's C1 and C2, and we just switch out C2 with Graal. You're still compiling with C1. So in this case, if we can compile this one method, it's not that big of an issue because we still have C1 compiled code. Okay? And that method was not a very hot method. It was not a business logic method. It was some core library method that just was a little lukewarm, and after a long time it got hot and got compiled on the latest tier. So it's fine, but it would still be nice to be fixed. So I kind of dropped it because I thought, whatever. But then this guy, I forgot his name, Leopold something, he fixed it at some point, and you can see it was actually 1,000 lines of code to fix it. So it was some work to be done. So that was the #1 bug. So when I saw it was fixed, I tried to verify if it was really fixed. And I was running it again, and I was grabbing the log, and you see there are some other exceptions coming out. The bailout exceptions, they're coming from Graal. He says, oh, I can compile it. And then Tom said, well, down here, problem with de-optimizing on static field access in CL-init, so the static class initializer. And there's a little piece of logic in C2's parser which allows access to static fields within the static class initializer for classes which aren't fully initialized yet. Okay, you see? The kind of chicken egg issue, catch-22 situation. You want to optimize on a static field, but you haven't initialized it yet. But since you are the compiler, so this is the little piece of logic here, it's called static field OK in CL-init. Okay? You're the compiler. You know what's happening. So you can say, okay, this has been initialized, and I'm just using the value. That's possible. And the bottom comment is the most important one, better to check now than to de-optimize as soon as we execute. That's the problem with static class initializers, because how often do you run them? Once, exactly. So usually they are not getting compiled. You just interpret them. If a static class initializer gets compiled, there's a reason for it. It's either very long, or it has loops in it. And if you're loading a class, I'm not saying all of your application, depending on where in the startup, where the class loading happens, but very likely all of your application waits for this class to be loaded, or at least part of it, right? So you want this to be happening as quickly as possible. So if it's already taking a very long time, and you are compiling it with tier 4, with the latest tier, it's hot, right? So you're waiting for it. You're spending the time to compile it, and then you would, run the compile code, and you would immediately de-optimize. Do people know what de-optimize is? Yeah, no. So it means you're running on compiled code, but you're hitting a situation, you were speculatively optimizing code, but then you hit a situation that you did not anticipate, and you can't run the code anymore, and then you have to fall back to the interpreter. Okay? So you're running interpreted again. And that's exactly what you want to avoid. Because if you're already wasting the time of compiling it and then running it, but you immediately fall back in the interpreter, there's no point. Okay, so this tiny little piece of logic here, we fixed it. It was very easy, 30 lines of code. It was very simple. We just ported over that little function, and that was it. Okay, so bug #2, that was a little more tricky. It's a fatal error, so it was a seg-v, right? And the annoying part here was, as you can see in my comment here, saying with long-running processes, couple days. So I was running the tweet service for a couple days, and then suddenly it crashed. And I thought, oh my God, this is always the worst case, because I had to run it in the data center and so on and so on. So it was very difficult. And then I didn't know exactly what to do, how to find out where it's crashing or why. So I had this kind of feeling that it might have to do with some command line options we're using or the service is using. And it turns out it's using something called Heapster. And it's an agent. And so Heapster is actually a GitHub project you can download for free. And it says it's an agent library to do heap profiling for JVM process. Remember, Graal is written in Java. So what do heap profiling agents do? They instrument bytecode, and they instrument new bytecodes. So if you allocate an object, it records the type. If you're allocating an array or an object array, it records that, and so on and so on. So you get a heap profile. So it was instrumenting code, but there is something called in Graal. Do we have another slide for this? Yeah. So let's talk about it here. So I was talking to Doug. He sits in Zurich, by the way. There's something called snippets. It's like an intrinsic. It's basically it's Java code. Java is used as a DSL in that sense in Graal. It's Java code that you can read as Java code, but it's never executed as Java code. It's parsed by the compiler into a graph, and then that graph is used to be inlined into your actual compilation. That's how it works. And so there is a snippet for double dot value off, right? And the problem is that double dot value off is using a new, okay? So the graph, when Graal starts up and it compiles all the snippets into compiler graphs, the bytecode was not instrumented yet. The bytecode instrumentation happened later, and so the compiled compiler graph and the bytecodes didn't match up anymore, right? Because if you instrument bytecode, your bytecode gets longer and there are other things in there. So that's why it crashed, because we tried to access bytecodes in the native memory of the JVM, and it was wrong at that point, right? So Tom and Doug discussed this, and then Doug at the bottom says, well, maybe it's time to bite the bullet and parse the bytecodes for snippets directly, right? So sounds easy, right? Took only 2,800 lines of code to do this. So that was an important one, because people in the real world use agents, right? They instrument bytecode. That's what people do. Like a lab, Oracle labs, they run spec-GPP 1,000 times, right? But they never encounter these issues. That's why I'm giving these talks, because I want you people to try this as well, because you have use cases that might be different, and there might be a bug still. We found these, but we only found them because I was actually using it at Twitter. So, okay, bug number 3. There was, for the longest time, I was seeing these connection exceptions flying by in the tweet service log file. And the problem is, if you have a huge, like Twitter, hundreds of microservice graph, and you have a connection exception in one of your services, you don't even know where it's coming from, right? It could be you. It could be one of the other 100 services you're talking to, maybe not hundreds, but tens. I didn't know what to do. I was new to microserver architecture anyway. I'm a JVM engineer. I know nothing about all this crap. So I really didn't know what to do. And so I dropped it kind of. And then I think independently, we decided to, internally, we decided to update the native version we're using. And I thought, okay, maybe it might be good to run the test suite just to see if it works. And then there is one called netty buffer, and boom, failure. Okay, so again, that's not good. So let's look at this one. And I was talking to Tom about this because it was reproducible, right, all the time. And as you might know, the number classes in the core library have a method called reverse bytes. So there is, for example, in this particular case, it's short.reverse bytes. It only swaps the bytes, right? It doesn't do anything else. And there is obviously a compiler intrinsic for this, because you can do it in Java code, which means a couple lines of code, or you can do it in one instruction on an x86, right? So there's an intrinsic for it. And it was wrong. It did the wrong thing. And the odd the odd thing about this bug was this is done all the time. Like all the freaking time this is used. But just in this particular instance, with that compiler graph, it was wrong. And so it turns out, so Tom looked at it and he saw the issue. 68 lines of code, that includes a test case because it was a copy-paste bug. It was 2 lines fixed, done. Okay. And that was it. These were all the bugs we found. And the last one, this one, go back, here we are, September 12, 2016. That's 2 years now. So since 2 years, we haven't had a single issue. No crash, no nothing with Graal. We are running all the services, the 4 important services that I listed earlier. We're running them on Graal 100% in production for more than a year now. And there are no issues. So it's stable. It runs really, really well, which you will see in a few minutes on a ton of graphs that I'm going to show you. The only thing is there might still be bugs hidden somewhere for use cases that we are not doing or that Oracle Labs is not doing. Again, I'm asking you, whatever you have, I'm sure you won't go Monday into work and turn it on for all your production service. That I understand. But you might have some staging environment, testing environment, maybe your own pet project or whatever. Give it a try. If it works, great. If it runs even better for you, even better. If it crashes, that would be amazing, because then we don't hit the problem. Okay. Good. I'm telling you about this one contribution that I did a while ago, I think a year ago. So a year ago, we didn't know yet what's going to happen with JDK, with the release cadence. So we thought, okay, 9 will be the next release. And I started to prepare ourselves to move to JDK 9. And one thing that JDK 9 has is compact strings. Okay? And so the way compact strings is implemented, it's a little unfortunate. I was still at Oracle at that time, and I was arguing very vehemently against it. It was implemented with handwritten assembly code. And the reason for that was we couldn't do it with unsafe because C2 wasn't able to optimize it. Yeah, hindsight. So there's handwritten assembly code now for a bunch of intrinsics. One is very long, and then 5-ish smaller ones that you have to do that do the compression and decompression of the bytes into characters. So there's a very highly optimized intrinsics that uses SSE, AVX, AVX 512, and so on. The thing that basically Intel did that I mentioned earlier. So and the way they are written, they're actually really intrinsics and not stubs. So we have to port them over into Graal, into Java code, so that we actually can use them. It's a very boring, labor-intense work because it's basically just taking C++ code and moving it into Java. But someone has to do it. So I ported the biggest intrinsics that there is. If you look at the third line at the top, this is Graal before the intrinsics. What is it? 2600 nanoseconds, and then with the patch, with the intrinsics, 126. So if strings are very long, obviously it helps. This is string.compare2. So if you're comparing 2 strings, and then obviously at the bottom, that's like C2. It's the same performance, right? We're porting the same thing over, so it has the same performance. We just want feature parity and definitely performance parity or better with C2. So we ported that. Then I didn't have time to finish it up because I started going to a lot of conferences. But Dimitri, he finished it up because he did the same thing for ARM64. And as you can see, it was about 1,000 lines of assembly code that needed to be ported over. So we did that. Good. And now the important part, or interesting, numbers. So I talked about the tweet service. It's a Finagle thrift service. So Finagle is one of these open source frameworks that we have on GitHub. And it's an extensible RPC system for the JVM used to construct high concurrency servers. I have no idea what it's doing. I The important part is it's almost 92% of Scala code. So I don't even know the percentage, but I would say 99.9% of our services are written in Scala. We only have a handful, two handful of services that are written in Java. And I think that's more historically than anything else. So Scala it is. The test setup I did was I used dedicated machines for this, same hardware, obviously. Dedicated machines because if I run it in a data center, we have multiple instances of something running on the same machine, right? There's a lot of crosstalking going on, and you want really a clean, iCache and data caches and all that stuff, and no crosstalking going on if you want to do real benchmark comparisons, because I did not know how big the difference would be. If you want to measure 1% improvement, right, you need a dedicated machine. So all the instances that I was running received the exact same requests. That's very, very important. It's not the same number of requests, it's the exact same request. Because a tweet can be 1 character long or 280. And so the allocation rate would be very different in that case. So all the instances, exact same requests, kind of data point, JVM CI that version, Graal that version. It's kind of oldish already because I think I did these experiments a year and a half ago, year and a half ago. I mentioned this earlier, we run default tiered, so C1 and Graal, right? So we compile with C1 first and then we compile with Graal. I'm not going too much into the bootstrapping issue here, but I have another talk recorded multiple times on YouTube. It's called how to use the new Graal, how to use the new chick compiler in the real world. And in that talk, I explain exactly what bootstrapping is, because the problem is, especially for us, because we're on JDK 8, you have to compile Graal as well. It's Java code, right? And there's a meta circularity involved, and that means there's a bootstrapping issue, because when you start up, Graal gets compiled, and so on. So if bootstrapping, we never had a problem with the bootstrapping actually, but if there is an issue and you can somehow move to a newer JDK like 10 or 11, you can AOT compile it and then that problem's gone. All right, so here we go. This is 24 hours of tweet requests. You see 4 different colors or not, and that's good because that means all of them receive the same the number of requests. You will notice one thing, it's not cut off, there is no y-axis. And the reason why there is no y-axis, because I'm not allowed to tell you. That's confidential data, I'm sorry. But you will see the way I show it to you later, you'll see how much the improvements are. So 24 hours. First we look at the tweet services using parallel GC. So we look at scavenge cycles here, and it's a moving average of 60 minutes, so it's kind of smoothened out, and you can see what's happening. So this is C2, and this is Graal. Remember earlier when I talked about partial escape analysis and the escape analysis implementation being better than C2's? That's exactly that. It can eliminate more object allocations than C2 can. You can't really tell right now how much it is, but you'll see in a second. And again, at that time, I thought we're moving to 9, so I was doing 9 as well, and 9 had its own Graal version in it, so I compared these two, and as you can see, it's exact same performance, so it's really no difference. We save about 2.5% of GC cycles, okay? It's not a lot, I understand, but it's something. If you don't have to do the GC, that's really, really nice, because the GCs always affect the P numbers, right? So this is something that a couple of our SREs called out. They observe their service really closely, and then they yell if something's out of bounds. And at this point, they yelled, "Oh, memory leak, memory leak." I said, "No, it's not a memory leak." What's happening is, so Graal uses a little more old gen, and the reason for this is it's a Java application. It has some state, right? Most of a compilation is very stateless. You get a request in, you do all the compilation, at the end you spit something out and you can remove, delete all the memory. But Graal still has some state, right? It has to be around, the compiler classes has to be around, objects that you can actually call to do the compilation, they have to be around. And at some point they will get promoted into old gen. But it's 40 megs, roughly. it's not growing or anything, right? So if your old gen is 100 megabytes, it will be 40. If your old gen is a terabyte, it will be 40. But it's good that our SREs actually noticed that. So this is the most important graph, right? User CPU time. That's the one we want to reduce, because that means if we can reduce the user CPU time, we can also reduce the size of whatever service we have, the instance size, and then reducing instance size means saving money because we are using less machines. And yes, we do. Again, you can tell how much, but we'll get there. C2 was slightly faster in this case. I'm not sure if that's actually really true or not. Could be some inlining decision that went in another direction than the run before, but Graal was exactly the same. And if I put this on a ratio, then I at least can show you a y-axis, and then you can already see it's quite a bit. And it's 11%. 11% of CPU reduction. I don't know how many compiler engineers are in this room, but if you're doing compiler optimization work and you get 1% out of it, you're happy, right? If you get 2% out of it, you probably go home and open a beer or more. But 11%, it's ridiculous. It's like a lottery win, really, right? And that was a big surprise to me that we could improve that much. So I said this earlier that we run the tweet service 100% on Graal in production, plus a couple more important services, big services, and then another 15 or 20 smaller services, because up to this point, I was moving services one by one. I was talking to the SREs. I had to convince them. You can imagine at the very beginning when I started working there, and I went to the first people and said, hey, I think I started even with the tweet service, if I remember correctly, kind of an important one, right? So if that one doesn't work, that would be embarrassing. But I said, hey, there's this new JVM chick compiler that's experimental and no one's using it. You want to try it? Difficult, very difficult. But there's a lot of hand-holding going on, or was. But once I had bigger services running on Graal successfully, then obviously it's easier. But in about a month or so, we'll switch over almost all of our services to Graal. That's kind of the next goal. Yes, and you should tweet right now to make sure that it actually works. But in the last year, you haven't lost any tweets, have you? So there you go. Good. So one question that was interesting to me was if this 11% CPU improvement is escape analysis, right? Because if you can eliminate object allocations, that means you don't have to call out into the VM and allocate the memory and blah, 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 blah. And your code gets much, much tighter because you can move the data into registers or wherever. And then on top of it, you don't have to collect all the garbage, right? So I thought, okay, is it maybe all coming from that? And so I was running an experiment where I turned off escape analysis for C2 and Graal. This is, again, 24 hours. It's a different day, so the graph looks different. And we're comparing C2 and Graal. And again, scavenge cycles, no escape analysis. So if we turned off escape analysis, how should that graph look like? Exactly the same, yes, because there is no elimination going on. So we verified that, and now we look at the CPU time, and there's actually an improvement. It's not as big as it was before, but there is one, and here in the ratio we can see 5%. So even just the different, I always say better, but let's say different, the different inlining implementation in Graal already gives you 5%, or us. That's also big, right? Because escape analysis only works for, applications that actually, where you can eliminate allocations. That's not always the case. With Scala, Scala allocates a lot of temporary objects, and C2 can get rid of them, can get rid of most of them, and then Graal with the better inlining, because the way it works, I don't want to get too deep, but since the inlining is better in Graal, it basically inlines more. That means escape analysis can also eliminate more object allocations, because it has to make sure that objects are not escaping. And if you inline more, you can see more of the world, and then you can tell, oh, I can get rid of that object. Should give a talk about escape analysis at one point, I think. So how much money are we saving? I cannot show you a y-axis. Do you think I can tell you how much money we're saving? Of course not. So we're kind of making up a company, and we look at some cloud providers. So I was Googling around how much is a cloud instance? How much is one CPU at certain cloud providers? And they're all listed in a weird way. And so I calculated it out, and it's between $72 per year per CPU and what, $210, okay? The number one takeaway from my talk today is, if you pick the wrong cloud provider, it doesn't matter what compiler you use, because you're wasting your money. So I thought, okay, whatever. We're making up stuff here anyway. So I was just averaging it out, $127 per year per CPU core, okay? So how many cores are we talking? So I cannot tell you how many cores we have, but there was an article, a Bloomberg article in 2014 that says, what does it say here? Amazon, multiple 28 total sets across the world, blah, blah, blah. Analyst, a conservative estimate puts Amazon over 1.5 million servers globally. And then another analyst at Gartner said 2 million servers. And then at the bottom, Microsoft, 100,000 servers spread across 6 data centers. Microsoft CEO Steve Ballmer said million servers. So, you know, I mean, ridiculous numbers, okay? We don't have 1 million servers at Twitter. We have enough. But these numbers, and these are servers, right? A server today has usually 24 cores. So if you can save 11% of that, you know, that's really a lot of money. Your company, as well as Google, as well as Twitter, is very likely smaller than Google. So we just pick a random number, 1,000 servers, okay? Might still be a lot for some of you. Some of you might work at the company that have thousands of servers. We definitely do. And then, as I said, each server usually has 24 cores. So let's say $127 per year per CPU core times 24 times 1,000 would be $3 million per year to just run whatever you run, right? And if you can save 11% of that, that's over $300,000. That's a lot of money to me. I don't know. It's more than I get paid. I don't know what you guys get paid, but it's more than I get paid. So that's nice, right? And even if you only have 100 servers, right, you would be saving $30,000 per year. That would be a nice Christmas party or something, right, company? So can we get more? Meaning, can we even save more CPU? And the answer is yes, we can. And so what I tried to do was, you know, there are a bunch of inlining parameters that you can tune with C2 and Graal as well. And so I thought, you know, I just fiddle around with them a little bit and see what I can do. So I was running a service, and then I was printing the compilation and inlining, and I looked at what was rejected, and then I tuned the parameters a little bit and to see where we can go. So this is the outcome. You might remember that graph. We've seen it before. There's just another color now. That's the experiment I was running with slightly changed inlining parameters. And scavenge cycle graph again. And as we can see, yes, it's actually slightly better. Okay, and it is 1.5% better. And that only because I fiddled around for 2 hours on a Friday afternoon with inlining parameters, right? So that's nice. But let's look at user CPU time, because that's where really the money is. It's also better. I was expected, obviously, here. Another 2%. So that's pretty cool, right? If we, what was it? $300,000 for 10%, so it's like 1% is $30,000, so $60,000 just on an afternoon. I wish I would get that money, but I don't. Yeah, they don't give it to me. I've asked. They don't. So this is really cool. I'm actually running right now and preparing right now my new talk about this topic, because there's something, we've done a talk about this before. It's called AutoTune. It's basically a machine learning framework that tunes JVM parameters. Because this is a stupid work, right? Like a monkey should do that. But we have machines, so leave the monkeys alone and let the machines do it. Because fiddling around with the parameters and finding the optimum, yeah, machines can do that. So this will be my next talk. So if I'm coming back next year, I'll give you that talk. I have to give it on Monday at Java 1. I'm still saying Java 1, by the way, because it will be Java 1 forever in our hearts. So we get more than 2, right? Because I could not find the perfect setting, obviously, but the machines can. But it's more than 2, I can tell you that now. Any official support, Graal support, that is, because I'm sure none of you has a JVM team at their company, so it's like some kind of support might be interesting to you. So there's CHEP 317, which Oracle finally has put Graal officially in the JDK. It was there in 9 as well because of AOT, but in 10 they said, okay, yeah, let's say we have an experimental-based JIT compiler. There are command line options you can turn on. You don't get the typical full support of Oracle, but at least you can turn it on, run it, and if it crashes for you, you can file a bug, and they'll probably fix it, very likely. So, oh yes, this is my other talk. I mentioned earlier how to use the new. It's basically an hour full of demoing how to do stuff, how to install Graal, how to turn it on, what to look out for when running benchmarks. Very important, because the first time you run something, you are used to how the VM worked and how C2 worked, and Graal is just slightly different, and you have to know these things. And if you know, you will look at the data in the right way and not misinterpret them. Yes, so watch that if you want. And then there is something called Project Metropolis, which was announced about a year ago. And at the bottom it says, incubate advanced Java and Java implementation techniques for hotspots. So that means, like Graal, implement the VM in Java itself. There have been, I don't know if people remember Maxine and Chixar VMs, so there have been prototypes in the past or research projects. We want to do that in OpenJDK 2. And then at the bottom it also says, our starting point is earlier proposals for using the Graal compiler and AOT static compilation technology to replace hotspot server compiler. Yes, that's exactly what we want. That's why I'm here. And possibly other components of hotspot. Could be anything, right? One thing that would be very interesting to replace would be the bytecode verifier. Bytecode verifier, the implementation C++ is hell on earth. In Java, it would be much easier to do. The other thing that would be really, really nice to replace would be the interpreter. The interpreter implementation is a lot of handwritten assembly code, and there are much, much better ways to do that. So I don't know anyone actively working on this right now. I would like to, but at Twitter there's really I don't have a business justification to work on it. But if someone's interested in that, please work on it. And then I have to admit, unfortunately, that this huge 10%, 11% improvement that we're seeing is mainly because we're using Scala. With Scala, there are just much more optimization opportunities for a couple reasons, but one obvious reason is hotspot and C2 have been optimized for Java code, right? Scala has been coming up lately, yes, but and it's around for a couple of years now, but still C2, as I said earlier, it wasn't really changed in the last couple of years. So it's still very much optimized for Java code. So if you run Java code on Graal, there's a 50% chance that it's better or slower. Most of the time it's about the same performance, which is already a win. If we can replace C2 with a newer technology and it runs with the same performance, yeah, great. If it's slower, yeah, it's also good and should be reported because we have to look at it. We have to know what's the problem and why it's not faster. And the other reason I want to mention is, so C2 and hotspot have been optimized for Java code, but also much more important is the Java code that's been written has been optimized for C2. It has been written in a way that the inlining always worked out and so on and so on. So you have to keep that in mind. But I've seen benchmarks where Graal was much, much better with Java code. So you have to give it a try. Your mileage may vary, as it always is the case. I have a summary for my talk. Very important. So this is how you turn it on. That's all you need. So you download a JDK 10 or 11. We're on 11 now. And you put this on your command line, and then you run with Graal. And that's all there is. So please try it out. Let me know if it works on Twitter, or if it doesn't work, file a bug on GitHub. And that was my talk. Thank you very much. Are we taking questions or no? No questions.